All right, here we go. A couple months ago, I put out a video on using OpenCV and TensorFlow inside of Unity, and some people had asked for the source code, which wasn't a major problem other than cleanup that I felt like I needed to do, and some of the integration work to make it run as seamlessly as possible. The reason being is I don't want to get inundated with developers that can't make stuff work, and some of that is my fault, and some of it is they don't understand how to integrate the project. And this project is kind of complicated because it uses OpenCV and because it uses the TensorFlow deep learning code. So to kind of get the ball rolling, I just uploaded the project on GitHub that should have the full-blown ready to run Unity project to test this thing out. As you can see, you're going to have to have the same software installed that I installed. I'm not going to try to make this stuff work on everybody else's hardware. So I've basically got Unity 2017.3.1. It's kind of old now, but you should be able to get this thing to work. So I'm just going to demo it real quick. You hit run, and basically you should be able to move the mouse around. This is kind of like the other demo that I did. You can hit the W key, the S key, the I think D key. You're basically trying to move around and get into position to do the object detection. And as you can see, this is a standard bitmap that is on the internet that you can use. Now, once you get into position, you just click the button, the left mouse button. On the bottom here, you can see that there is a string that gets emitted by the DLL, and this is a little bit more integrated than my first version, which just popped up the bitmap. And so what is now happening, we're not only sending the screen area, but we're also getting back a string that has the confidence and whatnot on the different objects it thinks it sees. I'm going to click it again. It says it sees a car, 80%. You can look down, you'll see a dog, you'll see a horse, you'll see a person. What I'm going to try to do later on is make the DLL that's we're calling emit JSON, and then that way the C# code can we can draw boxes around things, and we'll do translations on where those coordinates on the screen are relative to the objects that are currently on your screen. You have to hit escape to get the mouse back, and essentially that's it. Of course, there's a lot of complicated stuff going on underneath. This particular example that I'm submitting is not using a TensorFlow model. It is using a Caffe model that was previously built and trained that you can pull from the internet. I have it in this project so the DLL can find it, the OpenCVDotNet and whatnot. So what we basically have here is our capsule, which has the first person controller on it. I'm not going to go into any of this detail. if you guys are running this project, you should know what all this means. And I'm not trying to be disrespectful, but I'm not going to teach people how to use Unity. We've got a camera that we're moving around, and within that camera we have the object detection script, and this is where the rubber hits the road. The car, horse and lady, kite, people, these are just Unity objects with the sprite renderer on them with bitmaps. That's all that is. So you can add more things in here if you want to. Let's go down to what, and I have gone over this code before. I'll go over it again. The difference is that we're doing a pInvoke. I don't know if I want to call this up into, we'll go ahead and do it. Up into Visual Studio, which I think was already loaded. So sorry if my screen is too large. That's just the way it is, guys. I racked my brain. I had to rewrite this project a couple of times on the DLL because I have to use pInvoke in C# to get the thing to work. So anyway, we have just a standard object, a mono behavior called object detect. A lot of this code is the same code that was in the last example. When you do a mouse click, do a coroutine to do a capture. The biggest difference now is we are pInvoking on this DLL and it's returning a string. I don't necessarily know how memory friendly this code is. We're going from 2 different runtimes, but we'll just have to wait and see on that. So this code has been around before. We're essentially grabbing a texture. There might be a slicker way to do this within Unity. If you guys can find it, that's great. Get it to work, test the code, send the code to me, and I'll update the project. So the secret sauce is basically doing the marshalling between the image data and the string that gets returned. Right down here, and this is your log. So later on, we'll parse JSON so we can pull the coordinates out efficiently, and then we know what we're looking at and where the things are that were detected. Again, this is using what they call the single shot detector architecture on I believe it's MobileNet, SSD. There's a whole other world that you have to learn on these particular models, how they're trained, and things like that. I will later on go into some detail. It's turning out to be a lifelong journey for me. But this SSD I can run in Python and I can run in C#, as you will see, and it's not doing what they call inference like TensorFlow. It'll say inference, which is you pass a whole image to it and it says, hey, there's a cat in here. What the SSD is doing is it's finding multiple objects and it's returning bounding boxes and coordinates around what it thought it saw, which is super powerful. Okay, so this is basically all the code again for on the Unity side. I don't think I think that's basically it. The keys might be somewhere else as far as the movement is concerned. Anyway, we're going to get rid of this. Then we're going to get rid of this. And then what we're going to look at is what's getting uploaded. So this is a copy. Uh, don't freak out, but eventually GitHub will finish uploading, and it says TensorFlow in the name. It is, but it isn't, and here's why. This is a framework I'm building. I'm going to call it DeepLab. This particular project right in here is a tester. It will also build the OpenCV DLL, and it'll allow you to test it. Now you see these files in here. This is kind of important. The first test for you guys, if you want to do the same thing I'm doing, is you need to get this DeepLab project to compile and run. That's the biggest deal. If you can't get it to compile and run, then I don't know what to tell you. And I'm not trying to be rude and cocky. I will try to answer some questions, but you're going to have to know how to set environment variables. Obviously install OpenCV 3.4. That's all I'm dealing with right now. I'm not dealing with the older versions and the newer versions, simply because this particular version of OpenCV 3.4 can load models that I have trained in TensorFlow. And DeepLab maybe someday will be kind of a platform that I can use to train my models and then deploy them into either Unity or whatever else I want. So we have the Winform project here. This should look kind of familiar in my last video. We've got just the OpenCVDotNet. It's really not .NET. It was. I had some in whatever you call. It's not on the top of my head right now. It's just a pInvoke DLL. It used to have some managed C++ code in it that I could call in .NET. It was really slick, but it wouldn't work in Unity. So in Unity, what we have to do is things like this. This should look almost identical to what you saw in the Unity project, but we're in the Winform project. We have one button, opens up a file, and you will see the same code here. So this is basically doing the same thing, but in WinForms, so we can test our code. So you need to get this project to compile, and you need to get it running before you even try to change anything in the Unity project. You have to copy the DLLs over in the base directory. Maybe I'll make another video on that, seeing how far everybody can get. So we have object detect. I'm going to click on the same one I always do. I hit enter, bam. So this is the string that we get returned. Now this project is what I'm going to use to modify and get the JSON payloads working. In the Python version of this, when you run this, it will draw boxes around these the things that it finds. I've got some TensorFlow Sharp code that does almost the exact same thing, and it will draw around the images. Right now it's baby steps. I don't want to get people too hyped up about TensorFlow Sharp, because you got to go get the DLL, you got to add it to the project and things like that. So DeepLab, this is what I'm going to be using, and adding more code to the DLL in here. I've got other videos of this code, but I'll just show it real quick. It's much smaller now because we're only doing the Caffe SSD call. This is the money shot right here. This works very well. As you can see, it's very fast. It's relatively fast. Running inside of Unity, it was relatively fast. I had to kill myself trying to get this project to where it would build right. And not only build right, but also make it easy for people to pull down and get it to work. So this code is boilerplate. You know, it's basically, I've shown it in other videos. This is the fun stuff, which is basically taking the stream that you're getting back from these matrices. You know, this could be a whole other world, trying to figure out the inputs and the outputs of the Caffe model. There is a TensorFlow Keras version of this, but you have to, Keras is a simpler version of TensorFlow that rides on top. You can use it to train. That makes it easier. But at the end of the day, you have to get the models. You have to get these model files right, and they got to be able to load into OpenCV. And I've had huge issues. It's just not boilerplate. It just won't work. You just can't train a TensorFlow model and then bam, load it into OpenCV. There's a bunch of stuff you have to do to it, because you have to freeze it, and you have to rip out all of the training nodes that are in the model. That's what the people don't explain to anybody about when you try to deploy these models. Let alone, you don't even want to remotely try to train your own models. You want to use transfer learning and use existing weights that you load into the model. It's going to take you a year and a half to just figure out the TensorFlow Keras side of it. I don't care. I want to try to do the crude object detection and or other types of TensorFlow-like things inside of Unity, like voice detection, you name it. As soon as you can load the models, I currently have code that I'm trying to get to this same type thing in TensorFlow with my own trained model. So you know, stay tuned. Anyway, the code is in the process of being uploaded. There are some integration issues you're going to have to run into, which is you're going to have to and I'll try to put this in the README. I'll try to explain it the best I can. You know, it's taken me months to get some of this stuff set up to where I can understand it and get it to work. One of the biggest things that is a pain is that you have to do the integration. You obviously have to copy your models and your protobuf. These are the weights that get loaded into the model. These are the labels that the model needs to know that the thing it sees is a cat. So these three files have to be wherever this OpenCVDotNet DLL is. The other thing is it'd be nice to copy some images over, and this is a very important piece right here, which is essentially the environment variable that you have to have and you have to set up on your machine that points to where you downloaded and installed OpenCV 3.4. I happen to do it on my C drive, so I have an OpenCV 3.4 directory. I created an environment variable. This is super important to have set up right, simply because this project in C++ uses it in several different places. I've gone over this a little bit before, as you can see right here. Alright, it's in several different places. You have to have it. You can rename it, but you're going to have to modify the two prop files, debug and release. This also has it in there. So I know I'm going over it real fast. As we can see, this is debug. You need two files from OpenCV. One is the world. This is for 3.4. You got to be very careful because they like to rename things because they're little kids and they like to have fun, you know. But that makes it extremely pain in the butt trying to integrate this stuff. So I'll have this in a configuration video, I guess, if people are having issues. So I spent a couple more hours on this. I was in the process of taking a natural language class on Coursera. I work full time. You know, I just had about 2.5 cups of coffee. People were asking for this. So what you have to understand is that some of this is going to be hard for you. Some of it's going to be easy. If you download stuff and it doesn't work, please don't spam me with, well, I don't understand. You know, figure it out. If you can't figure it out, then it's okay to let me know what's going on. If it's entry level software development noob questions, I'm not going to answer it. Again, I'm not trying to insult everybody or anybody that might be at that level. It's taken me a couple of months to figure this out, and I've been doing development for over 20 years. So you have to know some C++, you have to know some C#, you have to know some marshalling, and then you have to know some environment and variables to get everything to work. Anyway, people were asking about this. I'm trying to do my best to get the code up there. The code isn't everything because obviously you have to do some integration work. I'll try to do my best to document it. If you've taken the time to go through this video and make notes, then you should be okay. I've shown you the majority of the stuff. Good luck. Have fun.